Good afternoon, everybody. My name is Pam Stokke-Cece, and I am the treasurer of the Wisconsin chapter of the Association of Corporate Counsel. We welcome you to this webinar presented by Quarles and Brady on a very timely subject, using IP to protect AI innovations. Quarles and Brady is a platinum sponsor for our chapter, for which we are very grateful, and we're pleased that Jonathan Stone, a partner at Quarles and Brady, and Joshua Walling, a patent agent at Milwaukee Tool, are here to speak on this topic. On behalf of ACC Wisconsin, I thank you all for attending this webinar. John, take it from there.
Thank you very much, Pam. So welcome and thank you for joining our webinar, as Pam stated, using IP to protect AI innovations, presented by Quarles. My name is John Stone. I'm a partner in our intellectual property group at Quarles. I largely work with universities, research institutions, and other companies that are at the cutting edge of technology. I practice focusing on helping those clients develop business-minded IP strategies to help them drive value for their technologies in various industries. Now, obviously, a large portion of my practice is delved into the area of AI and machine learning innovations, so happy to be having this conversation with everybody today. I'm joined by Josh Walling, as Pam stated, a patent agent, one of the great in-house patent agents at Milwaukee Tool. Josh, why don't you go ahead and give yourself a brief introduction?
Yeah, thanks, John. Hi, everybody. My name is Josh Walling. I'm a patent agent at Milwaukee Tool. Actually, Quarles is my alma mater, so to speak, so happy to be working together in this webinar. I manage a lot of the patent portfolio here at Milwaukee Tool, but one specific area that I manage is our AI and machine learning patent portfolio. And so a lot of my time here at the business can be spent doing exactly what we're about to talk about, which is helping the business understand, when should we be considering patent protection on our AI and machine learning innovations, and why.
Great, thanks, Josh. So we'll begin the presentation as soon as we just cover a few logistic items. First, all comments in today's webinar are off the record and are not for publication. All attendees are also in listen-only mode, but we welcome your questions via the Q&A box that's located below the slides in the webinar dashboard. If we don't have time to answer all the questions that we received during the presentation, we will follow up over email to make sure that your questions are answered. Quarles is happy to be able to provide CLE credit in most U.S. jurisdictions for our webinars. As of April of 2024, the American Bar Association manages the CLE applications, attendance submissions, and certificate of attendance for our external webinars. We've updated our procedures for tracking attendance for CLE credit. They include that you have to be logged in, participating from your own device, and need to actively watch the entire webinar. Please watch for pop-up polls that are going to be coming up with an audio notification during the presentation at several random times. You must click on those pop-up polls to verify your attendance. Regulators require attendance to be verified, and this procedure meets that requirement. Please take a moment to also review the resources box below the video feed, where you'll find a copy of today's presentation, a survey link to share your feedback, and CLE application information. You can access closed captioning if needed during the live webinar by clicking on the CC icon in the lower right-hand corner of the video player. Lastly, today's webinar is being recorded, and all registrants will receive an on-demand link within a few days to a copy of the video recording. With that, let's get started. So what we're going to talk about today is first just provide a contextual framework for AI. So understanding a basic definition, at least, of what we mean when we're talking about AI and the types of innovations that we're going to see with that. So you can help have this framework for analyzing your IP strategy. Then we're going to move into more discussion about some of those considerations for IP strategy. So patenting, how we would want to approach patenting these technologies, the weaknesses we might have with that. And then Josh and I are going to walk through some examples of trying to analyze some hypothetical situations from a perspective of patentability, but then also, just IP strategy in general. It may not make sense to patent every innovation, so what our options might we have through trade secret protection or the like. And then lastly, we're going to close out with some more strategic considerations, fitting in with this overall analysis of the IP strategy. A common question that we have dealing with AI and machine learning is, well, am I even going to be able to detect infringement if I go ahead and get a patent issued? So we'll talk through some thoughts on that, and then close out with just some overall strategic takeaways from bringing everything together that we've talked about. So to start, again, when we're talking about AI, it's a hard thing to really kind of pin down with a solid definition. But generally what we're talking about are technologies where you have some sort of system that is being programmed or taught or is learning in some way to mimic some sort of human intelligence. Within that, there is a subset of technologies that is referred to as machine learning, a term that I'm sure we're all very familiar with. And in machine learning, this is now where that system is going to be able to continue to learn with experience, to adapt to the way that it's interacting, to adapt to the way that it is performing some sort of output based on learning from that, the data that's being thrown at it, the training data that it's being used to further refine that model. Deep learning is another category of AI technologies that you'll hear a lot about. This is now a subset of machine learning. And in this context, we're usually looking at technologies that are utilizing a neural network type of architecture where you have multiple layers that are processing the data. So you get a much deeper intuitive sense of processing that data to get whatever output you're desiring. Now, despite the fact that ChatGPT has kind of blown the lid off of these technologies in the last year and a half and made it a much more sort of pop culture topic to be talking about, these technologies have been around for a very long time. So some common sort of groups of technology that we might have some more familiar interaction with. So image recognition, again, it's a human intelligence to trying to recognize an image. There's a great app that you can get for your phone that's by iNaturalist, where you're out on a hike, take a picture of a flower, it'll classify that image, figure out what the flower is that you took a picture of, and pull in information about the species, the range of where that flower might be found, things like that. Language processing, right? We've got Alexa, we've got Siri, using that voice command that gets transcoded into a text representation, and then is your phone or the Alexa system is then going to be performing some action based on understanding the content of whatever voice prompt you gave. Obviously now with ChatGPT as well, we now have language processing from the textual side and generating new text based on prompts that we're providing to that. Recommender systems like Netflix, you're watching a couple of shows and Netflix starts recommending new content for you. Again, that's that human process of trying to make a recommendation for us. AI is something that's being used for that. And now in the predictive sense too, right? In medical diagnostics, we're looking at this vast store of medical data and can we make predictions about whether somebody's going to have cancer or not, or if they're at increased risk for cancer. That sort of predictive forethought is another aspect where an AI technology can be behind that. And again, whether it's a more traditional AI like a rules engine or an expert system, or if it's machine learning or deep learning, any of those different types of systems can be used for these various different types of tasks. In terms of how we want to approach protecting these from IP, first we want to think about trade secrets. And trade secret can be very well suited for these technologies because at the heart of these technologies is data, right? These technologies are driven by amassing a large store of data, using that data to train the AI model, to train the machine learning model, and then utilizing that now out in product, whether it's cloud-based or edge device product. The data is really what drives the training of the model. Now the trained model itself has parameters that these are things that aren't going to be patent protectable, but if they remain in confidence and you have your systems in place internally as an organization to make sure that they remain in confidence, you can protect the data itself or protect the trained weights that are being used on a model through a trade secret. Obviously, the downsides with trade secrets is that if that information is ever leaked, it's out in the wild, you can't put it back, you can't put the cat back in the bag, it's now public knowledge. You're going to lose the protection that way. So it's important, as always, to make sure that you have a robust system in place to make sure that the information has remained confidential. And then also, there's always the threat of independent development. If somebody else has access to a similar type of data, maybe they can train a similar type of model, or if they're able to get their hands on any of your technology, is there a risk of reverse engineering? The flip side then is we have patent protection. And with patents, we're really now able to protect the method of using the AI technology. Maybe it's the method for training it, the systems that are ancillary to the technology that are being used to actually implement the AI. And the great thing about this is, we're always seeing this immediate issue and concern of, well, what about subject matter eligibility? Are these is it math? It's an abstract idea. It's this black box. Can we really protect that? And I think the beautiful thing with these technologies is they're almost always being viewed as a tool that's being used to solve a problem. So we always have a strong argument to be able to say that this technology is being integrated into a practical application, which we'll talk about in a little bit more detail later, really sets us up to be able to get stronger patent claims that are going to be able to withstand scrutiny under Section 101. So really what we want to be able to look at is the technology patentable from a 101 perspective? Again, the consideration of even if we get a patent on this, are we going to be able to detect if there's infringement? We'll talk about that as well. And ultimately, as Josh and I are going to walk this through, is there a good business case for pursuing patent protection, or is it going to make more sense to look at a different IP strategy through trade secret protection, or maybe nothing at all? And despite the fact that these technologies are very complex in nature, we can distill them down into simple components that really helps drive this analysis, or helps drive a more efficient analysis of figuring out what's going to be the most efficient and the most logical IP strategy for a given technology. So basic components for these technologies, we're always going to have some model, and it can be an off-the-shelf model. It doesn't have to be a new model that your researchers or your company is developing. It can be an existing off-the-shelf model that gets trained on some source of training data. And now that you have this trained model, you expose that model to a new input of data, and that's going to create some output. So you have these three basic components that we're able to take this, complicated technology, but break it down and just look at the data that we're using, the algorithm or the model at the heart of it all, and the outputs that are being generated. And again, the data can be the training data that you're using, that you've identified. Maybe there's a new type of data that's really relevant for the output that you're trying to create, or there's a new combination of inputs that is really driving innovation and getting better results than you were able to before, that your competitors were able to, or even just the process of training the model. And then really the outputs too, whether it's just an improved output, you'll be able to get better predictions, better classifications than people have been before, or you're able to create an entirely new output that people haven't thought about, or using those outputs to control some other further action that hasn't been done before. So looking at these three basic buckets, and unless you're a tech company that's really kind of innovating the newest neural network architecture, you're probably not having innovation in the model itself, but that's okay. We're looking at what improvements are there with the data, what improvements are there with the outputs, or looking at this holistically, how does this end up driving an improvement in the overall technology that our industry is operating in? Or is it that, again, we're using that output to drive some new control action on a system, and it's really maybe even that new control action where there's the innovation and we're able to protect it that way. And the great thing with this is then it may not necessarily matter what model is being used if we're focusing on the inputs and the outputs, how the functionality that is being created by using this technology. And that can really help set up a stronger patent position, because if we don't have to get into the weeds on using a very specific neural network architecture to get patentable claims, then that helps assuage some of these concerns that we might have with detecting infringement and things like that. So having this conceptual framework, at least for taking this complex technology, looking at these three simple buckets, the data, the model, and the output, is one piece of how we would want to try to approach figuring out a good IP strategy. The next piece is, how is this technology actually going to be implemented in products? How is it going to get used? And for that, I'm going to turn it over to Josh, who's going to talk through some of our options for general categories of how we might see these platforms being used. Josh, take it away.
Thanks, John. Yeah, there are three general categories of AI and ML platforms, or how AI and ML might be pushed out into the world. The first is an offline platform where you might be using AI or ML, but it's purely internal to your organization. So the training, the deploying of that model is just happening behind closed doors, so to speak. And then you might push the output or what that pre-trained model is onto a user-facing product or some edge device like a phone or a tool or anything really. The next type is server-based. So this is where the model and the training and the deployment of that itself exists on a server. This could be like cloud or some physical server farm somewhere. Or that server is hosting that pre-trained model, right? But nothing's happening on the device. The device typically would just receive the output. The last case, and how I think people most commonly perceive AI and ML innovations is this edge deployment case where the AI or the ML model like exists on the device or your phone itself and continues to like actively take in new data and learn. Diving into these a little bit deeper, the first type, as I had said, would be offline machine learning. This is actually super common. I think that you, as a consumer, might run into products that use some sort of algorithm or some sort of control strategy that was developed using AI or machine learning, but you wouldn't actually know. So in these cases, the training data is stored offline. The AI and machine learning is used offline to like push different updates or a control strategy or some new output to the tool or some product. And that output is stored on the tool. And so you can kind of look at this in two different ways. There's that vertical dashed line that's split in the middle. Everything to the left of that is actually really good to qualify for trade secret protection because you, as a user, will have no idea what's going on. You don't know what data is being used, and you don't know what machine learning controller is doing because all of that is happening, essentially in your R&D department. You think of companies like, or if you think of conventional trade secrets, companies like Coca-Cola is like, well, the ingredient list is trade secret. Or if you're a manufacturing company, you might have methods of manufacturing that you keep as trade secret. But in those cases, let's say someone just walks through the front door of your company with a camera, they can see what's going on. They can see the ingredients list or what have you. But machine learning and artificial intelligence is interesting in that even if someone were to walk through the front door of your company and get access to your R&D department, even then, it's really not obvious what's going on in the actual algorithm itself, right? The only thing that is typically detectable, and we're going to get into that detail later, is really what's going on with the output. What is happening in response to all of this data that is then end up being pushed out as something that's user-facing. The next type is server-based machine learning. This is kind of more of the same, except for it's just the model is stored on some server. This is also a really common type of AI and ML innovation. You can think of ChatGPT or Meta AI, which a lot of you are probably engaging with on Instagram and Facebook. The AI doesn't actually exist on your phone, right? You're just giving it inputs. It's being pushed out to some server somewhere, some cloud database where the AI and ML innovation actually exists, and then it's pushing an output back onto your phone. So training data is collected from other external devices. That training data is uploaded to the server, and then the algorithm exists on that server, determines some sort of action to take, and then pushes that action back out to the device itself. I think you'd think of the same things in this situation. You'd really want to look at the output. What's the action being taken? What is the thing that's detectable that someone might be like, oh, that's interesting. They must be doing something behind the scenes. That's the part you probably want to focus your efforts on for patentability. And then the last case is this edge device machine learning. Again, I think this is what people consider to be what actual AI and machine learning is, but it's probably the least common, at least for now, today, where training data is actively collected by this device. This device then executes an AI algorithm in real time to provide different outputs, and it's continuously learning. This is the least common, but actually you might find yourself in an interesting position here where if this is happening, your product, right? I mean, a lot of my expertise is through the space of consumer products, but your product might be marketed specifically as having this real-time machine learning controller on board. And if that's the case, you might be forced into a situation. We'll talk about that as a patentability consideration a little bit as well, but you might be forced into a situation where you have to or should try and patent it because the marketing department might make a lot of this information public anyways, just to help sell the product. So given all that, this base understanding of the main types of how machine learning is implemented into products today, I'm going to hand this back over to John, and he's going to talk about how to go about patenting AI and ML innovations.
Josh. So yeah, high-level strategy. First things first. We still have yet to really get solid, significant guidance from the Federal Circuit or district courts on the patentability of AI inventions. I think that's just the timing of new applications that are being filed, new patents that are being issued, probably just haven't worked their way through the courts yet. That's not to say that there isn't litigation around AI products, but the patents that are being asserted, for the most part, we're seeing are sort of these pre-Alice drafted app patents that surprisingly, not surprisingly, aren't really handling the scrutiny of the new subject matter eligibility test that has been promulgated by the courts over the years. So still waiting to see more significant guidance from the courts. But in the meantime, the USPTO has done an admirable job, I suppose, over the years of trying to provide guidance around subject matter eligibility of AI innovations. And just over the summer, they issued new guidance, again, non-binding, but they gave some guidance to the patent bar and provided more examples for where they internally view subject matter inventions being subject matter eligible and where they aren't. From an outside counsel perspective, there was nothing necessarily earth-shattering in the guidance that the USPTO provided, but it at least reaffirmed the best practices that we've adopted since the Alice and Bilski decisions and the Mayo test came out. And a lot of that then centers back on, wanting to be able to describe the architectural components of an AI with varying levels of abstraction, wanting to describe the process for how that model is being trained. So now not only for potential 112 issues of enablement and written description support, but then also just setting ourselves up to be able to get into this last point of, at the end of the day, if we are able to identify that there was a technical problem in the industry and AI is being used as a tool to solve that problem, now there's this practical application of this abstract mathematical box to solve that problem. And if we draft the application in a way that sets out that problem and construct the claims to align with the solution for that problem, this is where we're going to be in a good position to be able to articulate, even if this is an abstract idea, which maybe it's not, arguably, it's at a minimum integrated into a practical application. And this gets us back to our wonderful 4-part test for subject matter eligibility that's really supposed to just be 2 steps, even though there's 4 steps. And so we're really looking at these step 2A analysis when we're trying to understand where we have a good patent strategy for an AI innovation. First, can we craft claims in a way where we can argue that there isn't even an abstract idea being recited in the claims, but even if there is, now can we make that argument that the claims are at least integrating that abstract idea into a practical application? And so one strategy, again, is claiming the architecture itself. To the extent that we start claiming specific architectural elements of a model that's being used, that's going to help, at least on the subject matter eligibility side, of showing how this data is being processed specifically. We're using a specific network, even if we're just saying that it's been trained for a specific purpose, and causing whatever device it's processing on to run to perform a particular task. Those 3 things can be independent of each other, but we can look at those collectively as well. Obviously, the more detail that we're putting into our claim for a particular network that's being used is going to cut against us for detecting infringement. So there's going to be a cost-benefit analysis that you want to undertake, where if you need to start getting into those details to find a good claim strategy, maybe we have to start thinking about, are we going to be able to detect infringement? Is there maybe another strategy that's going to make more sense for this particular technology? The training process itself, as I said, so now kind of thinking back to those original buckets of the simple components for the AI system, if our innovation is, our researchers have identified new types of data that are being used to train a model, and that's creating a better output or a new type of output, we can patent that process itself of just training the model, not even having to use the model, but just training the model itself. And this is one of the examples that for years the USPTO has set out as being something that should be directed towards patent eligible subject matter. This process of training a neural network for facial detection was one of the examples that the USPTO has provided for us a while back. One caution here being is that if we have innovation around the training process, we want to make sure that you're drafting a claim strategy where you're separating the training process claims from maybe the inference claims of now using that trained model in product. And the reason being is we just want to try to avoid any sort of divide and infringement issues where if you had a claim that covers both training a model and then now using that model, well, if you have one party that's training the model and then providing that to a second party, and it's really only the second party that's using it, now you've got multiple actors. You may not be able to prove direct infringement under that circumstance. So a good strategy to think about, if we have a novel training process, we can protect that individually, but wanting to make sure that we don't muddy the waters on our claim strategy by tying things together that don't need to be tied together. And lastly, again, looking at this problem solution setup, if we're able to describe in our application where there's a technical problem, what the solution to that would be, and how the claimed subject matter is actually implementing that solution, by tying that back to the AI model, now we're able to articulate and argue that even if that model is viewed by the USPTO or the courts as being an abstract idea, it is at a minimum being integrated into a practical application. And this is, by and large, like the sweet spot that we can be in, right? If we have a problem, and as a company, we're trying to solve that problem, and we're using AI as a tool, and we've been able to now solve that problem. Again, as Josh kind of set up before, if we're looking at that output, and it's really that output that maybe has the value, it's that output that is unique and novel, the AI is just being used as a tool. And in some instances, we may end up finding out that the output that we've created, yes, we used AI to get to that point, but we may not even have to use AI to get to that point. And so it's just a stepping stone to this larger innovation. That would be sort of the best case scenario, where now you're able to protect the process of creating this output, with AI just being one example of what that might look like. And so that's going to kind of tee us up to, and we want to now kind of walk through some practical examples of some hypothetical situations for bringing this together. How can we look at these basic components of these technologies and now try to formulate an IP strategy under different considerations for where the novelty lies, where the real innovation is, and thinking back to not only the patentability, but again, where we might have a weaker patentability, is trade secret going to make sense? And so to kick this off, Josh is going to kind of walk us through just sort of some initial considerations that we were talking about, even from an in-house perspective, some of the things that you'd be thinking about before you even start getting into the weeds on the technology, just some initial considerations that you would have.
Yeah, thanks, John. There's a lot of interesting things to think about, and I think it's easy to be in the midst of prosecution and just sit there and focus on, is this patentable? And as John walked through, there's tons of paths to patentability, and so I think the more important part of the analysis is, well, should we be trying to patent this machine learning or AI innovation, right? And so I have some questions propped up here that I think, whether you're in the consumer product industry or in the tech space, that are good to consider, and actually can help you look like you're a really good business advisor for your client or for the company that you're working for. So where's the state of the art, in the competitive landscape? Are you the first to the AI ML game in your product space? Or is the state of the art already so complex that you're a little late to the game, and whatever it is you developed that was new might be so niche and so hidden in the weeds that this could impact your decision making on if this new innovation is in the methods of training. Is your training detectable, and is that something you should be pursuing? How will the product be marketed? I hinted at this a little bit earlier, but get to understand how this product or how this tech is going to be pushed out to the world. What are you going to talk about? And John has some really good examples we'll work through later, but if you're going to be admitting that AI is used in some way to provide the user with a better, improved output, then you might ought to just be forced into consideration of well, there goes any trade secret protection. Let's try and figure out how we should be patenting this technology. How detectable is the invention? This is actually extremely difficult. I think I hinted at a little bit earlier, detecting AI and ML innovations is extraordinarily hard. A lot of times these things exist in code. These are just lines of code on some firmware somewhere. And by and large, if you're a tech savvy company, that firmware is protected somehow. Like, it's encrypted. It's not just something you can plug a USB drive into and download all the text files and see exactly what's going on. They're extraordinarily hard to detect, with the exception being the thing that actually provides an output. What is happening in response to some control strategy? And lastly, how far ahead of the competitors are you? Are you on the cutting edge? And if so, if you're early, broad patent protection might be available to where you don't need to get into the nitty-gritty details of, the 4 million types of data you're using to train your algorithm. You might be able to get broad patent protection on the useful part, the part that is solving a problem that you needed to, that you leveraged AI to get there. If you're really far ahead, you can then balance that need to disclose information that might be trade secret with your ability to get broad patent protection. You might be in a ripe sweet spot. And to help focus this, John's framed up 3 different examples that we'll talk through to help drive the decision-making process.
Great, thanks, Josh. So the first example we have here, and to just tee this up a bit, so we have this sort of matrix on the left-hand side here. And again, we're looking at these, breaking things out into the data, the model, the outputs, and now the application of the technology. And so the check marks are indicating, on this far left column, maybe we have a new innovation in the training data that's being used. Or in the second column, there's a new innovation in the input data that we've identified, maybe identifying a particular type of data that might be useful for the output that we're looking at that other people haven't used before. The moving to the right on the columns, do we have a new model that we're using? Are we getting an improved output? Are we getting entirely new types of output data? Or are we just using this technology in a new application? And then lastly, there's sort of this measure of what the relative patentability might be based on those considerations. So this first example here, early on when AI and machine learning were starting to pick up in terms of the research activities, was a common scenario that we saw, and it's still a common scenario that we see today, where researcher is using an existing algorithm for just a new application, but they're really using the tool for its intended purpose. And as a result, they had to train it on new data, but maybe there's nothing really inspiring or interesting or different about the data that they used. So a common example would be, say I'm a neurologist, I have a colleague down the hall who's been using a convolutional neural network to segment medical images of the liver to identify lesions in those images of the liver. But again, I'm a neurologist, so I care about my patient's brains. So I want to use that idea, use a convolutional neural network, and now train it to segment images of the brain. Well, the input data is really still the same. It's still a medical image, probably even still the same type of medical image. It's really just that the image is depicting something slightly different. And so I had to train it on brain images instead of liver images. But at the end of the day, I'm using the same tool for the same purpose of trying to segment an image. It just so happens that different anatomy is showing those 2 images. These were the types of innovations that there's an uphill battle with obviousness here, where we're using this tool in its known way, just making slight modifications to how it's getting sort of teed up. Those were the areas where, at least from our outside counsel perspective, we looked at these and said, look, we're going to have some challenges with this. It doesn't mean that it's not going to make sense to move forward with the patent, but there's going to be a lot more risk with being able to get claims that might be reasonable. We maybe have to go super narrow to get claims allowed. And at that point, is that cutting against the detectability? Or it might be that, hey, great, we're not going to be able to get a strong patent position, so maybe trade secret makes sense. So with this type of example, Josh, what did you see if you saw something like this come across your desk? From the in-house side, what would be your thought process on how you would want to approach this and how you might go about trying to protect this?
Yeah, this is a tough spot to be in, to be honest, but it's one you find yourself often in. Some portion of the company somewhere has developed an AI innovation in, let's just say, like doing something in response to like an over temperature condition, and they just happen to use like a static AI model to get there. Maybe that was developed on drills, and then you have a second side of the company that's doing recip saws, and it's like, we love that. That innovation is now spreading like wildfire throughout the company, and everyone's finding new applications to use the same technology for. That situation's tough because even though it's providing usefulness in a new application, you might be better served just trying to, maybe you have an earlier filing for that original invention, and you're often better served just trying to rescope your claims. Otherwise, if you have no earlier filing, the only thing that's really new here is your training data and your input data, which are often things that are hard for others to see from the outside, right? Like, this is not stuff that's going to be public. And not only is it not public, I have no idea how you detect this short of someone giving a detailed TED talk on how this is working, or your marketing department revealing the secret sauce of how the bread is made, so to speak. So this would be a tough case to be in, but again, I think providing this level of education to your internal clients or your external clients can sort of help them understand that you're a team player, rather than being considered something that's like in the way of filing innovations. Everyone gets excited about innovation, so it can actually be hard to say, like, well, in this case, we shouldn't be patenting it for these reasons. And it's not that I don't agree with how exciting this is. It's just that it's more valuable to be a trade secret than anything else.
Yeah, and I think that's one good point too, is right at the heart of this is the data. And so if you know that you've amassed a unique data set that's really driving this innovation, even if there's patentability concerns with it, if nobody else has a similar type of data set, and if it's going to require your competitors years and resources to try to recreate a similar type of data set, exactly, you can still get that competitive advantage in the market, even if you don't have a patent position to really stand on. So even just by protecting your data, keeping it in-house, protecting it through trade secret, you can still get that competitive advantage depending on, the availability of the data or similar types of data in the industry. So the next example, moving us slightly more towards maybe we've got a stronger patent position, is, again, we're using an existing algorithm, we're using a new type of training data or a new type of input, but now instead of just using that tool for the same similar task in a different application, we're actually, based on what we've done with the training data or based on what we've identified with the inputs to use, we're actually getting a better output than people have been able to do before. So an example might be, people have used an AI model to identify performance issues in a broadband network before, and maybe they trained that model and then used inputs that were based on service logs, maybe technical details about the components in the network. But now you've come along and realized that, hey, we're sitting on this mountain of customer complaint data, right? Everybody's complaining to us when their internet drops out. Well, there's rich information in that if we use that as an additional training input and now use that as a new input to the trained model, we're actually able to better predict where the components are failing in our network, and we're getting a better result. So this is a scenario now where the analysis is going to shift to, well, what's the new input? What's the new training data? And now was it really obvious to think about using that new type of input or using that new type of training process to arrive at this better, improved output? And so now that's where that inflection point, if we can make a good case that it's not obvious to have used this new type of data, then great, we're in a stronger position for patentability. We could have some good claims that might be broad in scope that is reasonable to us, and we could move forward with protection. Or if we're arguing, no, that's kind of an obvious thought to use this additional type of data, that's where you might now start running into more issues again, moving in the other direction where maybe it isn't as patentable. So Josh, similar sort of question to you. In this case, where now you're starting to see there's some improvement in the outputs, how does that sway your thinking on this?
I think, again, it's a tough situation to be in. One good lens to maybe look at this through is where the state of the art is at in your industry. If you're really, really far ahead and let's say the improved output is like greater accuracy of achieving some torque value or something like that, right? Can you just market that and have that be your, your stronghold in the market is just having a better product? And do you necessarily need patent protection to be able to do that? Or is the state of the art kind of close to you? You just think that you figured this out and it's only a matter of time in the near future that someone's going to be on your heels figuring this out as well. Then you might start to think about some of the intrinsic benefits of having patent protection, even if it's difficult to detect infringement. There's a lot of inherent benefits of patent protection, even outside of having that benefit of clear infringement detection. So I would probably evaluate against the state of the art and let that be like a bigger driving factor.
Great. So then our last example is going to be, again, existing algorithm. So still no innovation there. Doesn't necessarily matter for our considerations here. Again, using some new type of training data or some new type of input data, but now we're not just getting an improved output, we're getting some entirely new output altogether. So maybe it's a different type of prediction, a different type of classification, or it's using the output that we're creating from the model to do some further action, controlling a device in some particular way that hasn't been done before. So an example might be using computer vision algorithms to detect defective fruit that are moving down a conveyor line. That computer vision algorithm component isn't anything new, but now after we've detected, hey, this fruit is defective, now we're using that output to control some action that's going to remove that fruit from the line. Maybe it's a mechanical arm that sweeps the fruit off or compressed air that pushes the fruit off. And if nobody's done that type of control action before, now the innovation really is, again, we're using AI as a tool to get us to a point that we're able to do something that people haven't been able to do before. So whether it's an entirely new output itself or using an output in a way that is novel and non-obvious in and of itself, these are really going to be now the use cases where we feel like you've got the strongest position for patentability right out of the gates. Josh, thoughts here? Obviously, great position to be in, not always going to be able to be in this situation, but when you have something like this come across your desk, how are you feeling and what are your thoughts on how to approach it?
Yeah, this is, like you said, this is the golden position to be in. A lot of times when I see this, the conversations I'll have with engineers is, okay, cool. We used machine learning and what we did was something new. The tool is doing something new in response to a bunch of data. Is machine learning the invention, or is really this new way of controlling a tool the invention? It's in most cases the latter, right? You want to get your internal clients or the inventor refocused on, hey, like, stop giving AI this stranglehold on your attention that really, I think you've developed something new in and of itself, irregardless of whether AI was used to develop that or some more, conventional, hard-coded algorithm that isn't just learning and adapting in real time. If learning and adapting in real time exists in your claim and that's the thing that's going to give you patentability, then you're no longer in the realm of, well, your output is new. But if your output is new and the tool control strategy or whatever new output is going on to some device, if that's new in and of itself, then that's the real innovation, and we should have a refocused conversation on not only can this be done with AI, but hey, let's start ideating around some other ways that we can accomplish the same thing outside of using AI, and then hopefully get even broader patent protection on this new control strategy without having it be limited to some specific ML K-factor algorithm or something like that,
Great, thanks. So we talked through these examples and we keep dancing around this idea and this concept of we're balancing these considerations against, are we even able to detect infringement or potentially detect infringement or enough that there might be infringement going on with these technologies? So I want to dive in a little bit to some strategies that we have on this in particular. So of course, we've got our esteemed Sherlock Holmes investigating patent infringements. Of course, can't have a presentation on AI without using an AI generated image, but here you go, patent investigator Sherlock Holmes. So things that we can think about, again, if we want to be in a position, and we're usually in a position where the AI is a tool that we are either molding in some particular way based on the training that we've come up with or the inputs that we're using, or in combination or in isolation, we're creating some new outputs. We're using that output in a way, like Josh explained, to control a tool in a new and interesting way. The AI model itself now, yes, is this magic black box, but it becomes secondary to really what the focus of our claim strategy is going to be. It's secondary then in terms of what we're going to be able to protect. And as a result, now, unlike traditional software claims where we had to get into specific functions that are being called and the flow of data between different systems, that really starts getting into the weeds on things that will be more difficult to detect for infringement. With this IP strategy around AI models, where the AI is really just a tool that's being used and molded in a way to create some output, now we can shift that focus in the analysis for detecting infringement to what claim features can be observed. What are our competitors marketing, and can we identify potential infringement through that? Because we're looking at this higher level. We're not caring about what's going on inside the black box. It's what's going into the box and what's coming out. That's really the focus of the claim strategy. In reverse engineering, there might be regulatory authorities that sort of put some impetus on the types of information that have to be disclosed by our competitors that can help us figure these things out. So from a first point, just observing the claim features themselves, right? If our innovation, again, is in the inputs or the training, is it a specific type of user input being used, the type of data being collected, the sensors that are being used to collect that data? Those are things that can be observed, detected, again, through marketing literature. Maybe we can actually see what our competitors are doing. And if that's where more of the claim strategy is focused on, or if it's focused on the output that's being created, if these are observable features, again, it may not matter what's going on inside this magic black box that is the AI model. It's the inputs and the outputs that are really relevant to our claims. And it's those inputs and outputs that might be observable and then relevant for us to be able to more successfully detect, or at least infer that there's a strong possibility that a competitor might be infringing our claims. And again, this might hinge on understanding your industry, knowing what marketing materials are going to be produced by your competitors. Are there technical specifications that are routinely published? Are there user manuals that might hint at some of these things? Understanding what your competitors are likely to publish is going to help inform your confidence in, are we going to have a stronger ability to potentially detect possible infringement by looking at the inputs and the outputs? And some examples here might be, if you go onto iRobot's website and look at their Roomba or Nest's website, they have these high-level discussions about the Roomba. It's using object detection. It's going to capture an image. It's going to provide that image back to the user so that the user can provide input as to whether there's an object that needs to be avoided in future runs. Or it's the Nest thermostat that's learning about your presence in a room and building a schedule for your temperature around you, right? So it's starting to give you some hint as to, what's the output of an AI model that's being used and what might be some inputs that might inform how those decisions are being made by that model. Netflix, on their website, goes into a little more detail about the types of data that they collect and that they use in determining their recommendations for new content to you. So if you had a system, a recommender system for providing content to users that used input about how long somebody watched content or the time of day that they watched it, and you had claims that were focused on using those inputs to create a recommendation for content to a new user, this information from Netflix would be enough to start giving you these red flag that they might be infringing on, a claim that you have. Or again, Oracle Financial Services has an entire user manual on some of their machine learning technologies that you would be able to dig through on a nice, relaxing Saturday afternoon if you really wanted to sit down and read a technical manual on machine learning. But again, based on the industry, there might be more detailed information available to you that might give you these insights. And lastly, another example here is Adobe. Again, highlighting at a high level the types of machine learning actions that they are using, both on their cloud services, making content aware suggestions to users. Again, understanding what types of outputs they're creating, giving you a hint of what type of information they would be using to make those determinations. This can help give you some insight into whether somebody might be infringing potential claims. Again, reverse engineering is an option. This is now going to be much more technically challenging. It's not going to be trivial, but it is at least something to be aware of that, as Josh was saying, especially with that edge case where the AI model is residing on a product that's going to be in a user's hands or in a consumer's hands. If your competitor is able to get their hands on a software executable, can they decompile it? And even if they are decompiling it and that code is encrypted, they can't read line by line what your software is doing. A lot of the AI model implementations, people are using existing models. They're using publicly available libraries for performing certain functions. And so even if that software code being decompiled is encrypted and indecipherable, there might be patterns and structures that people can relate to these known models or to these known libraries that might allow a really skilled software engineer to infer some insight as to what models are being used, how the data variables are being passed through those models. So there might be some possibility of inferring potential implementation that way. Or even with a cloud-based server where you're not able to get access to that software that's running, just applying inputs and measuring the outputs might allow you to deduce some inference as to how the AI is working. Lastly, there might be regulatory requirements for disclosure. So with GDPR as an example, Article 22 of GDPR says that if you are having some automated decision-making process that is being based solely on personal data, there are going to be some disclosure obligations for that, meaning that meaningful information about the logic involved has to be disclosed in certain circumstances. And again, that's not going to give you a roadmap for exactly what your competitor is doing, but it will allow you to have some insights that you might be able to infer the potential for infringement. So again, even though some of these things are being built around this black box that the AI model is, by focusing on what the inputs and the outputs are, both for your claim strategy, it puts you in a stronger position, but then allows you some of this flexibility in being able to determine the potential for infringement. And so we were just going to close just with strategic takeaways, which are really just kind of synthesizing everything that we've talked about. And in the interest of time, I think we'll move kind of quickly through these slides so that we could get to any potential questions. But Josh, sort of the first things here. So obviously, looking at these three components, we're looking at training data as the innovation or using the input data. As we kind of talked about, this is a good case where if the data is really what's novel and interesting here, especially if this is a data set that's not readily available to somebody else or not easy for somebody else to reproduce, yes, we could patent a training process. Yes, we could patent the process of using that input data, but also trade secret protection could be useful. Any additional thoughts on sort of this scenario where the data is really at the heart of the innovation?
No, yeah, I mean, trade secret protection is going to lend itself really well. But and really importantly, I mean, especially to those that are on the webinar, that when you're outside counsel representing a client that does AI innovations, or if you're in-house counsel, meet with your business leadership, meet with your engineering leadership, and walk them through your concerns of patenting or not patenting, and essentially make it a proactive conversation between you and business leadership of why it is you're recommending certain decisions. But yeah, I mean, this would lend itself well to trade secret protection.
So next consideration, again, unless you're a tech company that's really innovating new models themselves, right? You're OpenAI and you've developed the next level of transformer that's really going to drive better predictive outputs from ChatGPT. Probably not looking at protecting the model itself, but this would be, again, the blended instance of the software code itself could be protected through copyright. It's limited protection, really. It's just going to protect somebody from literally copying line by line your code. So really, again, you'd be looking at, can we protect our software code for this new model through trade secret? Can we protect the learned parameters through trade secret by not allowing other people to get access to them? Or again, you could have a patent position, but now these claims might be narrower, and now you're running up against these consideration against, now I'm into the weeds on the black box, what's happening inside of it? Is this going to be more difficult to detect potential infringement? But moving on to, again, where there's innovation in the outputs, you're getting better results, you're getting new results. As we talked through, this is a great spot, right? If you're creating something new, you're generating some new output, a good place for innovation. Josh, any closing thoughts on this scenario?
Yeah, I mean, this is best case scenario. So I think that if you're having conversations with your clients, this is the thing to hone in on is whatever is happening in response to some input, is that in and of itself new? And if so, let's now like dive in on this and think pretty seriously about patent protection.
And again, keep in mind that it might be the new training data that you've identified as being relevant, or the new input data that you've identified as being relevant, that really drives the innovation on the back end with the output. So it may not just be that you have strictly innovation on the outputs or strictly innovation on the inputs. They're many times working in unison, and collectively then they provide this overall combination of these that strengthen the position that you might have with patentability, or may strengthen your decision that trade secret would be more appropriate. And although we focused a lot on the algorithms, the inputs, the outputs, the data itself, I know Milwaukee Tool isn't in the business, I hope, of creating smart toasters that are going to run amok, but the AI model itself, again, is a tool that might lend itself to controlling a system in a new way, and maybe it's the control of that system that is useful and interesting. Or again, it is just to get AI to work on that user product is going to require redesigning that user product in some way. So there can be these ancillary features that can be protectable, that can really, because we started with AI, start driving further innovation, where now we've got entirely different strategies around now maybe the more comfortable, more routine types of patent protection around innovations on new devices. So to close, again, just the big picture takeaways here. With these technologies, AI and machine learning, there's this tension, there's this balance that we always want to be thinking about between trade secret protection, patent protection, where is it going to make sense, where is it not going to make sense? And by distilling things down, again, these more complicated technologies to these simplified components of what's going on with the data, what's going on with the output, what model's being used, and what application are we using these technologies. Hopefully our conversation today has empowered you to just understand maybe a more efficient way to approach these technologies, to work through these problems and try to figure out what might be the most appropriate IP strategy for the innovations that are going on at your businesses, or the innovations that you are counseling others on how to go about protecting. With that, thank you very much for your time this afternoon. We appreciated the opportunity to speak with everybody. We'll turn it over if there are any questions. I'm not seeing any immediately in the Q&A box, but if there are any questions now, do feel free to post those. Or again, if you want to follow up with questions after the fact, feel free to email and either Josh or myself, and we would be happy to follow up offline with anybody. Great. Well, seeing nothing immediate here. Josh, again, thank you for your time in participating. I appreciated your insights from the in-house counsel side of, it's easy for us to be in the weeds on the outside counsel, how we want to be advising our clients in these situations. I appreciated your context for the decision makers that you have to report to and the things that you're thinking about and considering with these ideas, and how we can work together to align our strategies with your business. So thank you again for your time. I appreciate it. And thank you again, everybody, for joining us this afternoon. Take care and have a great rest of your day.